This is continuing lesson 11.2 and also a lesson 11.3. So probability is the likelihood that an event will occur. We're going to look at geometric probability. So the likelihood, the event that we're looking for is to land in a specific region of an object. So the area of the region is the what we're looking for it to happen, and the whole area is all of the possibility that it could have been. So we're looking for, is it going to hit this part out of the whole thing? So let's find the probability the dart would land in the shaded region. So that means we're going to have to do shaded over whole, and that's going to give us our probability. So the shaded part is going to be the big circle minus the little circle, and the whole thing will just be the big circle. So for our big circle, we have a radius of 4. So the big circle is pi times 4 squared, or 16 pi. And I'm going to leave it in terms of pi because everything's going to be in terms of pi, and it's easier to deal with these numbers without the decimals. My small circle has a radius of 2. So we're going to do pi times 2 squared, which is 4 pi. So the shaded part is going to be 16 pi minus the 4 pi, or 12 pi. So shaded is 12 pi over the whole thing, which is 16 pi. So the pi's cancel. We're left with 12 over 16, which is 3 over 4. Or we could turn this into a percentage by dividing 3 by 4 and multiplying it by 100, 75%. I believe on something like our final, it'll be written as the fraction, but I'm fine with you giving it to me as the percentage because sometimes our fractions will be gross looking. They'll have decimals and things like that. So here's one for you to try. Find the probability that a dart would land in the shaded region. If you'd like to pause now, you can. Answers are posted online. And now let's get into 11.3. Imagine we have a polygon inscribed in a circle. The center of the circle C is also the center of the polygon. So polygons can have centers, and especially we're going to be dealing with regular polygons. And if you remember what regular means, it's equilateral and equiangular. The radius of the circle, like CA or CB, would also be a radius of the polygon. The only difference is a circle has an infinite number of radii, whereas the polygon will only have as many as it has vertices. Now we have a new segment that only appears in the polygons. It does not appear in the circle because it is the segment perpendicular to the side of the polygon from the center, like segment CD. And that is called the apothem, right? Sounds like a possum with a lisp, the apothem. So the apothem is going to be very important for us to be able to find the area of one of these figures. So let's just identify one thing from each of these because there's many radii, there's many sides. Let's just name one. So a radius of the polygon would be anything from the center to a vertex. So like AB is a radius of the polygon. The center of the polygon is point A. The apothem. So that has to go from the center perpendicular to the side. So I only see one point that's perpendicular to anything, and that's J. So it would be AJ is our apothem. And a side of the polygon, JB would not be one, JI would not be one because that's not a full side. I would need something like BI to be the full side of the polygon. We know a central angle in a circle is an angle formed by two radii from the center, and that's the same thing here for our polygon. But now we have a very specific measure for the central angle because the radii are going to be equally spaced apart. Right? If I drew all the radii here, I end up with exactly 6 central angles that are all exactly the same. So if a circle adds to 360 and there are n equal central angles, we're going to find the measure of a central angle by doing 360 divided by n. So for example 3, let's find the measure of the central angle of a pentagon. N would be 5 in a pentagon. So 360 divided by 5 is 72 degrees. For an octagon, n is 8. So I would do 360 divided by 8, or 45 degrees. It is possible for our central angle to be a decimal. If it is, we'll just round it to the hundredth. I'm telling you that because you're going to have to do that in the tries if you choose to do them. So here's some problems to try. Pause if you'd like. Answers are posted online. The perimeter of a regular polygon, a regular n-gon, is S times n. S is going to represent the side length, and n is the number of sides. That's the same as when we originally learned about polygons in Chapter 7. The area, which is one of my favorite formulas of all time, is 1/2 times n times a times s, or 1/2 nas. N is going to be the number of sides again, a is the length of the apothem, and s is the side length, just like it was in the perimeter. So for example 4, we want to find the area and perimeter of a regular pentagon with s equals 16 and a equals 11. Now there's not going to be any real work for us to do in this, but every time I'm finding area of a polygon, I'm going to set up on the side n equals, a equals, and s equals. It helps me organize my information. It helps me know that I'm using the right things in the problem. And it's going to help the teacher, me, know what exactly you thought things represented in this problem, especially because I just told you it's a pentagon. So I should be able to see that you know n equals 5. The apothem A is 11 and the side is 16. So if I want the perimeter, which is S times N, that's going to be 16 times 5. So the perimeter is really 80, and we're going to include our units, feet. The area is 1/2 nas. So that's going to be 1/2 times our whole list, 5 times 11 times 16. So on our calculator, we're going to multiply all those, and we get an area of 440 feet squared. So here's one for you to try. Just the area. You can pause if you'd like. Answers are posted online. Example 5. We're going to find the area of this polygon. I'm going to set up n equals, a equals, s equals. So I can count the number of sides, right? This is a pentagon. We have 5 sides. That 15 in our picture, now we have to figure out what the 15 is representing. I could see that this segment goes from the center to the side perpendicularly. So that would be the apothem. That means we don't know how long the side is. Unknown to us. So here's what we're going to have to do. We're going to have to find out how long the side is before we could find the area of the polygon. This is half of the side, right? This is 0.5 of the side. And I can draw a right triangle here using a radius. This angle is only half of what would have been measured as a central angle, right? If I drew both radii, this would be a whole central angle. This one here is only half of that. So what we're going to do is we're going to create our right triangle each time where the height of the triangle is the apothem, the bottom of the triangle is 0.5 of s, half of the side, the hypotenuse is the radius, and our angle is half of a central angle. If I did 360 over n for the central angle and then multiplied it by 1/2, I'm going to get 1 times 360 on top and 2 times down on the bottom. So this formula will give us directly the angle we need for our problem. So I'm going to set up this triangle. I'm never going to draw it on the picture because it can get very confusing and messy if we're trying to focus on the picture. So I'm going to redraw my right triangle. I know this is the apothem, which is 15. I didn't know anything about the side, so it's 0.5s. I'm not going to put the radius on here because it's not part of my formula. The only time I'll include the radius is if I'm using a circle for something or if they give me the radius. But my angle is going to be 360 divided by double 5, 360 divided by 10, or 36 degrees. We're going to have to use SOHCAHTOA to solve for our missing side. So using SOHCAHTOA, I have O and A. Unless we're using the radius, we're always going to be using O and A, so we're always going to be using tangent. It's when the radius is involved that we'll probably use both sine and cosine to find a and s. So tangent 36 equals 0.5s over 15. So I know that 0.5s was on the top, so that will equal 15 times the tangent of 36. So 0.5s, if I do 15 times tangent 36, I get 10.898, so 10.9. And my last step is to divide both sides by 0.5. So S is really 21.796 or 21.8. So now I have everything I need to do my 1/2 NAS. It's going to be 1/2 times my whole list. So 1/2 times 5 times 15 times 21.8. And we get a total area of 817.5. And I don't even think they gave us units on this, so I'm going to just say units squared. So here's one for you to try. You could pause if you'd like. Answer is posted online. Now we're going to look at one where we're not given the apothem. So let's set up our n equals a equals s equals. There's 1, 2, 3, 4, 5, 6, 7, 8 sides. And this 11 is on the outside. It's one of my sides. So I'm going to put 11 for s. And like I said, we're going to start with a right triangle every time. I don't know a this time, so I'm going to put the letter a there. I do know how long the side is, and the bottom of this is 0.5 times 11, or 5.5. And my angle will be 360 divided by double 8, or 360 divided by 16, which is 22.5. So again, tangent 22.5 equals 5.5 over a. This time my variable's on the bottom, so a will really equal tangent of 22.5 divided by, oh, I'm writing this all wrong. Oh my goodness, nobody's stopping me. 5.5 divided by tangent of 22.5. And when I do that on my calculator, I get an apothem length of 13.28. So now I have enough to find my area, right? 1/2 times 8 times 13.28 times 11. And we get an area of 584.32. We have units this time, inches squared. So there's one here for you to try. Pause. Answers are posted online. Example 7. Let's set it up. N equals A equals S equals. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides for this shape. This 12 is inside, but it doesn't go to the middle of the side with a right angle. It goes to a vertex. So 12 is actually the radius in this problem, which means we don't know A or S. So we're going to have to find both of them. So I'm going to put the letter A and the 0.5s on my triangle, and the 12 can go here as the hypotenuse. My angle will be 360 divided by double the 10, so 360 divided by 20 is 18 degrees. So like I said earlier, when we want to find both A and S, we're going to have to do both sine and cosine. So let's start with sine. Sine of 18 equals, and we're going to put O over H, 0.5s over 12. So I'm going to end up saying 0.5s equals 12 times sine of 18. So 0.5s is really equal to 3.71. And when I divide by 0.5, I get 7.42. And now we're going to do cosine. So cosine 18 equals, now it's A over H, so A over 12. So A will really equal 12 times the cosine of 18, which is 11.41. So now we can find our area, 1/2 times our whole list, 0.5 times 10 times 11.41 times 7.42. And I get an area of 423.31. And again, no units on this one, so I'm just going to write units squared. Here's one for you to try. Pause if you'd like. Answers are posted online. And for our final problem, we're going to bring it back to the beginning of our lesson, and we're going to combine it with what we just learned. We're going to find the probability a dart would land in the shaded region. So the shaded region is really the circle minus the pentagon, and the whole thing is the circle. So we're going to do circle minus pentagon over circle. So that means I need to know the radius for the circle. I know the side length of the pentagon. I need to know the apothem of the pentagon. So I'm going to still set up my n equals a equals s equals like I normally would, because I need the pentagon no matter what. I know my pentagon is n is 5 and 12 is my side. So I don't know a yet, and I will need r as well for the circle. So I'm going to put r on my picture, I'm going to put a on my picture, and the bottom is half of 12, or 6, and my angle is 360 divided by 10, because n is 5, so 36 degrees. So let's start by finding the apothem. So that's going to be tangent. Tan 36 equals 6 over a. A is on the bottom, so it's going to be division. A equals 6 over tan 36. And using my handy-dandy calculator, I get 8.26 for A. So I can already find the area of the pentagon. 1/2 times 5 times 8.26 times 12. And I get the area of the pentagon is 247.8. All right, so that's going to go there. I still have to find the radius to get the area of the circle. So I'm going to use sine, right? O and H. Sine of 36 equals 6 over r. So that means r will be 6 divided by sine of 36. So r is 10.2. I'm going to switch how this looks for a second, just so it doesn't get too small. So our circle area is pi times that squared. So our circle area is really 326.85. So that means my shaded part, circle minus pentagon, is going to be 79.05. All right, let's see the whole thing again. So I now have the area of the circle. I don't know why I'm boxing. Oh, sorry. The area of the shaded now is this whole top. And this part here was the bottom. So we're going to do 79.05 over the whole circle, 326.85. And you could see why we would want this to be written as a percentage now, because these are some gross decimals. So I get 24.3%. And that is the end of 11.2 and 11.3.